something a bit different, in the sense that I've written a script, and that this is an educational video, unlike my previous work. But anyways, today I will be describing the behind-the-scenes look at reality as you know it, and maybe you will learn something on the way. Or, you know, your brain might explode. So, warning for those who have limited brain capacity, your brain will explode upon hearing this information. Okay, are you ready? Good, because we're starting. So what do you already know about reality?
It's full of cruel people and Donald Trump is going to take over the world and...
No, not that! What do you know about, how do I put this? The building blocks of reality.
Well, atoms?
Yes, good, atoms. There were 5 different variations of them. Or 6, I forgot. Anyway, what you may know about atoms is that they consist of 3 fundamental particles. The proton and neutron, making up the nucleus, and the electron, orbiting the nucleus. Spoiler alert, that's not entirely accurate. The electron is actually not orbiting, but appearing around the nucleus in different spots very fast, making up a cloud of probability where the electron might be at a certain time, but you don't know that because literally everyone draws atoms like this and not this. Convenience. Duh. However, even though the atom makes up everything, you may wonder what each particle is made out of. And that is the question we are going to answer today. But before we do, I need to introduce you to the standard model of particle physics and the 4 fundamental forces of the universe.
Okay, this is getting a little bit complicated.
Shush! There are 17 known particles in the standard model as of 2020, divided up into 3 categories, which make up reality as we know it. To understand how these particles work, we must think of the universe like a game of chess. The particles are the pieces, the 4 fundamental forces are the rules, and the board is the universe. Each particle, or piece, follows their distinctive rule as per the forces of the universe. So what are these pieces, and what is their purpose? Let's go back to the atom. The nucleus, made out of hadrons, can actually be divided up into even smaller particles inside these hadrons, called quarks. In a proton, we see 2 of what are called up quarks and 1 down quark. For the neutron, there are 2 down quarks and 1 up quark. Usually there are 3, but in select hadrons, like the recently discovered pentaquark, hadrons can have 4 or even 5 quarks in them. However, in reality for you and me, there are 3 only. These quarks are part of the first category, 2 out of 6 total quarks. Variations of the up quark, the charm and top quark, and variations of the down quark, the strange and bottom quark, fill in the rest of the quark category. But what about the electron? Well, the electron is its own particle in the leptons, the second category, with 5 other variations. The close relatives of the electron, the muon and tau, and their neutrino versions. Together, the quarks and the leptons make up the fermions, the particles that make up everything in the universe. In your everyday atom, you will see quantities of up and down quarks and electrons appearing around the nucleus.
Wait, what about the other particles, the muon?
It's muon! Gosh dang it, I don't get paid enough. Well, these other particles don't exist in everyday matter, despite being close relatives to the up and down quarks and the electron. If you want to observe these particles, visit a particle accelerator, like the Hadron Collider in Switzerland, to see these particles get made from high-energy particle collisions. Also, it has been theorized that the strange quark had been made in large quantities in the Big Bang, and since they are extremely stable and can exist on their own, could be floating around in the universe, waiting to strike a planet or a star and cause the end of the universe, because once it strikes a celestial body, it will cause that celestial body to turn into strange matter, which causes more things to turn into strange matter and ending life as we know it.
Coder, you're rambling again.
Right, sorry. It's all theories anyway. Strange matter is about as strange as your mom anyway.
Excuse me? Wait, Wait, you said there were only 17 particles. I only counted 12. What are the other particles?
Bosons. Good old bosons. The nerds of the universe, always following the rules.
You mean the forces?
Yes. The four forces of the universe are the nuclear forces, the strong and weak force, the electromagnetic force, and, as you may know, gravity. Something else to note is that there are certain fields in the universe, named after the bosons, that penetrate everything we know, that the bosons are constantly interacting with, like throwing a stone into a smooth pond, with the ripples being the effects. Okay, Ellie, are you ready? We're gonna do a quiz.
Okay.
The first boson is called the photon. Which force does it carry? A, the electromagnetic force, B, the strong force, C, the weak force, or D, gravity?
Gravity?
Sorry, that is incorrect. The correct answer is A, electromagnetic force.
But doesn't the photon carry light?
Yeah, but let me explain. Light, I mean visible light as we see, is part of the electromagnetic spectrum, accompanying wavelengths such as microwaves, no, not that microwave, radio waves, and gamma rays, which come from black holes shortly after a star goes into a supernova, causing hot jets of gamma rays to eject from the black hole. And if they're pointed at the Earth, it could rupture the ozone layer, allowing violet, ultraviolet light from the sun to burn the Earth and cook all of us alive.
Potter, you're rambling again.
Will you cut it out? Anyway, electromagnetism is also the reason electrons orbit, appear, around the nucleus as well. The electron and nucleus exchange photons, allowing the electron to stay near the nucleus at all times. Bet you didn't know that. Okay, Elodie, another question. The next boson is the gluon. What force does it carry? A, the electromagnetic force, B, the strong force, C, the weak force, or D,
Gravity.
no. This time it's B, the strong force. Gluons can be found in the nucleus of an atom. They are in between the quarks, holding them together. Like gravity holds atoms together to create objects, but different because this is subatomic scale we're talking about here. Next question. The next boson is the W boson. Which force does it carry? A, the electromagnetic...
Gravity.
No! It's the weak force! What about the Z boson? A...
Gravity.
Holy sh**! No! It's the weak force!
But you already said...
Just listen! The W and Z bosons work together to carry the weak force, which is responsible for a multitude of things. One is radioactive decay, which allows scientists to study isotopes of fossils using radiometric dating, among other things. Another is fusion of atoms, a critical process of the sun's inner workings, allowing the sun to use its heat and the weak force to fuse atoms, releasing heat and sunlight to us on Earth. Okay, final question. I trust that you've got this. The final boson is the Higgs boson. Which force does it...
Gravity?
You little... The Higgs boson, contrary to what many think, does not carry gravity. Instead, it interacts with the Higgs field, the field that gives all particles their mass, which means the Higgs field is especially important, as is the Higgs boson. Unfortunately, unlike all the other fields, it may not have yet reached its ground state, which means that the Higgs boson has a lot of potential energy that could be released via quantum tunneling, like a ball rolling down a hill, with so much energy it causes a complete breakdown of the universe, allowing the stable Higgs field to penetrate the whole universe, deleting everything it encounters with, including Earth, destroying chemistry itself, meaning life will never again exist, and the whole universe will end as we know.
Potter! You need to stop saying we're all gonna die!
But they need to know.
No, maybe you should worry about the 2020 election instead of this end of the universe.
Yes. Donald Trump
Talk about gravity.
Shh. Shh. Oh, fine. Unlike all the other forces, gravity does not actually have a distinctive boson, making it a thorn in the scientist's side. Theoretical physicists everywhere, like Sheldon Cooper, are trying to marry gravity to the standard model using additional theories like string theory and coming up with a unified field theory that explains everything. For all we know, gravity could have its own boson like a graviton or not. We don't know yet. So, in conclusion, the universe, while being made up of extremely small atoms, is actually amazingly simple. Whatever something is made out of, if you zoom in enough, you will see 17 elementary particles playing a game with 4 forces as the rules on this playing board that is reality. And as for the multitude of ways the universe could end, right now we should be focused on more important things, like COVID, the alien disease that Area 51 attempted to cover but spread to the whole world. So stay safe, and good luck with the stump that is Trump. Bye.
You have just been demonetized.
What, why? This was supposed to be an educational video. No, hold on, wait, hang on, wait. The electron orbiting the nucleus. Elodie, if you want to fall out of your chair now, I'm good with that, because this is a long pause.
Yeah.
I need to introduce you to the...
Baby shark doo 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 doo, baby shark doo doo. Wee wee ow.
But what about the electron? Well, the electron is its own particle in the leptons, the second category, with 5 other variations. The close relatives of the electron...
The muon.
It's muon! Darn it, hang on. I think you said it correctly. Oh wait, you're like hesitant. You're like, Calder? You're rambling again.
Okay. Calder?
No, like you're scared of me.
Calder?
No, not that.
Wait, you said there were 17 particles. Oh no.
What happened to you? Sweet.
Even you said.
Shush! What are you doing?
I'm not doing anything.
What are you doing? At least sit back in your chair or something.
There's a mouse, run away! There's a mouse, there's a mouse, there's a mouse!
It's outside the window!